During this presentation, I'm going to talk about two research studies that have indicated how students can learn best. My hope from this video is that you take away some ideas to enhance or shift your study habits to improve your performance on the next exam and on the final for our exam in Chem 142. The first study I'm going to talk about briefly was a study that was done and published a couple years ago that talks about different learning techniques. What you'll see from this slide is that the study I'm discussing investigated the success of using 10 different learning techniques to determine which ones work best. They involve things like elaborative learning, where you have to generate an explanation of why for something, self-explanation, which has you explain something with respect to something you already know, summarization, which basically asks you to summarize things. Number 4 is highlighting and underlining, which is often a study strategy students use when reading. Making mnemonics to help remember certain words, using imagery to recall facts, rereading test material, using practice testing to evaluate if you've learned material, using distributed practice, which means spreading your practice out over time, or using interleaved practice, which means mixing up the types of practice that you do within a single study session. From these techniques, they evaluated all 10 and found that some have low success rates, some have moderate success rates, and some have high success rates. You'll notice the two best practices involve practice testing and distributed practice. As a reminder, practice testing is self-testing or taking practice tests over to-be-learned material, whereas distributed practice is implementing a schedule of practice that spreads study activities out over time. What's interesting about these two techniques is that both strategies have been shown to work well over a range of ages and across a range of disciplines. That means that if you use practice testing and distributed practice as part of your learning for classes, that you can use these same study strategies well beyond Chem 142. So in the case of practice testing, that doesn't mean just trying the practice test in this class. This means taking, for example, your notes, trying a problem that we worked out in class, cover up the answer, and see if you can replicate what we did in class. Similarly, it's using homework problems from the back of the book and trying to see if you can get the correct answer. Distributed practice tells us that we should spread our studying out over time. We all know that cramming for a test is not the best way to learn material for the long haul. Perhaps you have a good memory and can manage to cram right before a test, but to truly learn the material and make it stick, you need to practice that learning over time. Now, the second study I want to talk about was published a couple years ago in the Journal of Chemical Education. What this study talked about is using a single 50-minute study session to help improve students' scores after their first exam if it didn't go very well. This work was conducted at LSU, and they provided a nice PowerPoint with some of the results from their study, so I'm going to use some of their slides to help illustrate the point of the importance of thinking about thinking when it comes to your learning. In this study conducted at LSU, they showed that students who did poorly on a first exam but then were taught important learning strategies were able to modify their learning behavior in the course and begin to excel. For example, these 3 students all started out with failing or barely passing grades in their first exam, but after attending a 50-minute seminar about learning strategies, they were able to vastly improve their exam scores and end up with final grades of A's in the class. Now, I realize we're starting after the second exam, but I think some of these study strategies are still important to try at this point during the term if you need to improve your performance. One of the key tips that I would like to offer is that you need to get the most out of the homework that you do. You should be trying to do homework as early as possible. So when we talk about a section in class, you should then go try to do that homework as early as possible, preferably the day that it's assigned. The tricky part about this is that it's really tempting with our textbook to flip to the back to see either example problems or what the answer might be. You should really try to force yourself to try the problem without the use of your notes or without looking at answers if at all possible. Within that trying, you shouldn't give up so early that you didn't really try it fully. You should never give up the question before 15 minutes, but you should also never spend too much time on a given question. So based on these studies done at LSU, they posted some averages for students that attended their learning strategies seminar and those that did not attend. And what you'll notice is that the ones that attended were able to bring up their average course grade after the first exam into the B range, but on average, those that did not attend the learning strategy session still maintained a C average in the class. And the only difference between these two groups of people was whether or not they attended one 50-minute presentation. Now I'm summarizing the high points of this presentation so that it's not nearly 50 minutes long, but my hope is that you'll still reap some of the benefits of what a 50-minute session would have provided. This is just another example from instead of fall 2010, now fall 2011, where you'll see the same trend occurred in a following year just because of that one study session. So what's the goal? The goal of having you watch this presentation is to analyze what you're currently doing to learn general chemistry concepts. What I would like to happen is for you to understand what changes you could make to implement so that you can improve your course grade. Then you'll have these concrete strategies that you can use not just in our term, but in other courses. And ultimately the goal is for you to become a more efficient learner by studying smarter instead of harder. So what's the difference between studying chemistry and learning chemistry? So I'd like for you to think about this for a second. What would you have to work harder to do? Would you have to work harder to get an A on an exam? Or would you have to work harder to be able to teach that material to the class? To do well in Gen Chem, you should try to learn the material, not just study the material. You should be studying the material as if you had to teach the material, not just get an A on the test. That ability to learn material and then explain it to someone else proves that you have a much deeper understanding of the material than simply spitting back what notes you've already been given in class. So why is thinking about all of this so important? Well, I think you've realized by now, if you're watching this video, that this class is hard. It's going to be much harder than what you saw in high school chemistry and much harder than what you did in Chem 141. Part of that's because we have to move at a fast pace and material is cumulative, and so it continues to build on itself. Oftentimes there's many steps within a problem, and so that when you're given a test, sometimes those questions don't look familiar, but if you have learned all of the concepts, the goal is to be able to apply multiple concepts at one time. So in this second study at LSU, what they really hoped to do was to teach students about this concept of metacognition and how to become an expert learner in chemistry, and hopefully you can still apply those same goals to non-chemistry concepts. So metacognition, you may have never heard of that word before. Metacognition is simply thinking about thinking. It's being aware of what you're doing so that you can be a conscientious problem solver. It asks you that during class and during your study sessions that you monitor and control your mental processing. Meaning, did I understand what she just said in class? Do I understand why I'm doing this particular setup for a chemical equation or this particular setup for a math problem? The goal of metacognition is to have you accurately judge how well you are learning something. So Bloom's taxonomy, you may have never heard of this before. I would never quiz you on something like this, but what it tells us is that when we are learning, there's different levels of learning. At the bottom of this pyramid is knowledge. Knowledge is just us being able to memorize facts and give that information back. That means you could have memorized something in a different language, have absolutely no understanding of it, but you've memorized it so you could spit it back if you had to. Knowledge and memorization is the lowest level of Bloom's taxonomy. Our goal is to take ourselves from these lower parts of the pyramid and work our way up to more higher order thinking to improve your learning capability. So knowledge, and then the second component, comprehension, is being able to restate something by maybe paraphrasing or summarizing something. Knowledge and comprehension are taught heavily in high school, and these should be skills you've already got a good handle on. But in college, we're asking you to also apply and analyze various information. Application is certainly one of the things we ask a lot of you in Chem 142. It asks you to use information to solve problems. And then analyzing different information asks you to identify components and then make arrangements or logical statements based on that information. To some extent, we also ask you to synthesize and to evaluate information, but typically that's a material that you become much more of an expert at in graduate school. Synthesizing means combining new information to create something unique, versus evaluating means making decisions once you understand all of the other pieces of knowledge at play. So what really we're hoping to do out of a seminar like this is to amp up your ability to apply and analyze information. So how do you move yourself up higher on that pyramid? We have something called the study cycle, and I think of all of the slides that I'm presenting to you today, this is one of the most important slides. The study cycle asks you how you can make the most out of going to class, preparing for class, reviewing after class, studying for an exam. So you'll notice the first thing that we ask you to do is come prepared to class by previewing the class. Don't be afraid to look at your chapter. It's why I ask you to watch Chem Tour videos. Make notes if you have to. Come prepared to understand the basic objectives and that are happening within the unit of material that we're covering. So all of those things combined are going to make you more prepared when you come to class. Then the next step is to actually attend class. This is typically not a problem for most students, but certainly something to be considered. You should go to class and be an active learner in class, meaning answer questions, ask questions, and take meaningful notes. Sometimes that means writing down more than just what gets written on the board if it's something that's going to help you understand what was written on the board. The third step in the study cycle is review after class. Don't bury those notes away or lose them and not look at them for weeks. You should review the material shortly after class, read the notes, fill in any gaps you might have, or write down any questions that you might have to ask in the next class or during office hours. From there, you should study. And repetition is key for studying. You shouldn't just be memorizing the material, but you should be saying, why do we do this setup for a reaction? How do we set it up? What if we set it up a different way? In studying, one of the things you can do is have intense study sessions, which are 3 to 5 short study sessions per day. Within an intense study session, you'll notice at the bottom of the slide, it can be broken up that within, up to an hour of time, you've got different goals within each of those increments of time during the study session. The first thing you should do when you sit down to study is have a goal for yourself. Is it finishing 5 problems? Is it memorizing something you've been asked to memorize? Set that goal for yourself. Then, for about 30 to 50 minutes, interact with the material, whether it's rereading, filling in notes, trying a problem. Really focus with that material so that after that 30 to 50 minute interval, you can reward yourself. Take a break, chat with a friend, go for a short walk, and really give yourself a little bit of a break so that then you can, for another 5 minutes, briefly go through what you learned in that past hour to make sure it really sinks in. From there, you need to assess. That's the final piece of the study cycle. Don't just get so bogged down with, oh, I need to write this lab report, or oh, I'm trying to keep up with all these homework problems. Really figure out, are you using good strategies to help you learn the material, and do you understand it well enough that you could teach it to somebody else? That's the trick. If you can teach something to somebody else, then you truly have a good understanding of it. So you should strive to be the one that can explain a concept to somebody else. So, from all of this, what are some good metacognitive strategies? One should always be to strive to solve a problem without looking at an example or without looking at a solution. Of course, that might be a great place to start, but by the end of your study, before an exam, you should be able to solve a problem without looking at your notes or the answers in the back of the book. The next effective strategy is to memorize everything you're told to memorize. So in this class, I don't ask you to memorize a lot of things, but when I do, I let you know. And so don't throw away an opportunity by not memorizing something like the polyatomic ions if I've asked you to memorize those. From there, the third strategy is always be cognizant of what's happening. Ask questions like why, how, what if. These are going to develop a deeper level of understanding. The fourth strategy is test your understanding by giving mini lectures on concepts. If you have a study buddy, try to explain something to them. See if they understand what you're explaining as the way they understand it to test if you understood the concept. The fifth strategy is spend time every day on chemistry. It doesn't have to be a lot of time, but a little bit every day, just like I showed you with the first study, is the best roadmap for truly learning the material over a period of time. The sixth piece of advice is use the study cycle we just talked about and include those intense study sessions. The next one, attend SI sessions. That's a remnant from the PowerPoint that I got from this study. Really, don't be afraid to attend EDGE if you need to. Review sessions with me or Michelle or David. Go to office hours if you need them, either with me or the other professors. Use those opportunities available to you to help you study. And finally, aim for 100% mastery versus 90%, because it's hard to gauge what that 90% looks like, so you should aim to know it all. On Wednesday, I asked students that did well on the exam what helped them do well. These 5 reasons may not be in the exact order of importance, but these are things I've heard time and time again that help to prove the students that do well what helped them. I often get feedback that attending the review session I offer is a huge benefit to students. In fact, when I was a student, I was the type that was a little quiet and didn't ask a lot of questions in class, but generally understood the material. But I still saw an immense amount of value in going to a review session. Maybe I didn't have a lot of questions for the professor, but it helped me solidify my understanding by going to that final review session and making sure I knew all of the material. The second reason many students gave was actually doing the practice exam. The practice exam is not the exam you'll be getting in class, but is a good representation of assessing whether or not you've mastered the material. The third reason is they said they used the book and always did the suggested homework problems. When needed, they made flashcards to memorize important information, and some even said that they did well on the exam by practicing what they know and explaining it to others. So how do you get the most out of your homework? We've talked about this a little bit already. You want to start the problems early. I would say aim for maybe 6 book problems per day. That's not a lot. And you'll notice that the book problems are very similar to the SmartWorks. So if you start with the book problems, by the time you get to SmartWorks, it shouldn't be that difficult. Do not flip to the back to see the example problems. Work on them on your own, and then spend an appropriate amount of time, not too much or not too little, on a given question. So how do you get the most out of times when you're looking for help, whether it's office hours, edge, or study sessions? I want you to try the material on your own first before you come and ask for help. Don't be afraid to look back in the chapter or look through your notes on a first attempt at something, but at some point you have to get comfortable enough with the material to be able to do it without additional help. So if you do come for help, try something first and then come prepared to ask questions and then be able to explain the material to a tutor or myself or other classmates. So most importantly, out of this seminar, what I want to know is what strategy have you learned from this seminar that you can use in the next couple of weeks to help you on exam 3 and help you on the final. As part of your Blackboard quiz associated with watching this video, I'm going to ask you to set this goal for yourself. I realize I asked it initially when I handed out note cards in class on Wednesday, but now that you've learned some new study strategies, I want you to tell me what's most striking and to make you rethink how you would study for the class. And finally, hopefully listening to this seminar has given you a sense of what options you have and might be different approaches to studying. But if you don't enact some of those changes in the next couple of days, you probably never will. So start now. Open the book. Try a couple problems. Do a couple of SmartWorks questions. Really challenge yourself. My hope is that for those of you who've sat through this entire video, I will be able to report to the class after exam 3 a vast improvement in exam averages for this exam compared to exams 1 or exams 2. So rise to that challenge and prove to yourself that it's not because the material is so difficult that you can't do it, but instead do things like distribute your practice over time and truly test yourself of the material to prove that you've learned it. Thank you for listening to this video. I hope, if anything, this has given you some tools that will help you not just in chemistry, but in all of your classes to come.